Welcome everyone. So this is our fourth lecture of electromagnetic waves. Okay. So in last class we discussed about energy density and also we discussed some numerical problems as well. So in this class also we first discuss some numerical question, then we will study the radiation pressure and the intensity of the radiation, these two things, and again we will do some another numerical problems as well. So let me start with a brief recap of energy density. Okay, what was that energy density? As we know that in electromagnetic waves there are two fields essentially, that electric field and magnetic field. E and B, right? So as electric field is there and magnetic field is there, there are some energy is all corresponding to the electric field energy density and also for the magnetic field as well. Okay, so let us define the energy density. I am not going to derive again as I derived in the last class. Energy density for the electric field. Okay, what is the energy density for the electric field? That is denoted as UE, right? So it is actually, let me write it, U is half epsilon naught, it's 1 by 4 epsilon naught E naught square. Okay, and energy density for the magnetic field, what was that? UB or UM, you can write any of them, UM or UB, that is also 1 by 4 and nu naught C B naught square, right? Yes. Okay, this is the energy density for the magnetic field. Now what will be the total energy density? As both electric field and magnetic field both are present in electromagnetic radiation, so there should be total energy density, that will be the sum of the energy density for the electric field and the energy density for the magnetic field. We have to make the sum. Okay, so okay, there is no C actually. Yes, mu naught is under. Okay, it's correct. Now total energy density. That should be U equals to UE plus UM. Now what was E? It is just 1 by 4 epsilon naught E naught square and UM is 1 by 4 mu naught B naught square, right? Again we know that B naught is equal to E naught divided by C. If we put it here, then we will obtain that, as I did in the last class also. Let me repeat it. It will be E naught square by C square, and also we know that C square is 1 by mu naught epsilon naught. So if we put it here, then we will obtain again this. So it is UE. So essentially UE and UM is the equal. So U should be 2UE equals to 2UM equals to, you can write it 1 by 2 epsilon naught E naught square, or we can write 1 by 2 mu naught B naught square, or we can write 1 by 2 mu naught H naught square, where we know that H naught times mu naught equals to B naught. Okay, so this is our total energy density. Correct. Actually, this is for a if we took the total oscillation, then it will be the average energy density. Let me write it. For a complete cycle, the average value can be written as energy density actually. Okay, these things are all, these are all average actually, these are all average. These are average, but for a complete cycle we can write U average is equal to U. So it's clear. So ultimately this is the form of U. Okay, let me start with this class with a problem. First state me the problem. What is the problem? Okay, so this type of problem I have also done in the last class. Let me do again. Electric field of an electromagnetic wave is E is given, which is 10 to the power minus 5 sine 12 into 10 to the power 15 t minus 4 into 10 to the power 7 x. Okay, now they ask to find frequency, velocity, wavelength of the wave. This is the first part of the question, and also they have asked to write the equation of the magnetic field corresponding to the wave. Okay, so these are two questions. Okay, first they have given this is the electric field. We all know that, we have already discussed several times that we can write E is equal to E0 sine omega t minus kx. So now if we compare, then easily we can write that E0 is equal to 10 to the power minus 5. Okay, again if we compare omega is 12 into 10 to the power 15. So omega is angular frequency, right? So angular frequency, and if we again compare k, the wave vector is 4 into 10 to the power 7. Okay, it is radiation per second, and this is actually the wave vector. Kappa is 2 pi by lambda, that means it is actually meter. Okay, everything is in SI unit, that is also given in the question. So now if omega is there, we have to find out the frequency. What is the relation between frequency and angular frequency? We know that we can write omega is equal to 2 pi nu, where nu is the frequency and omega is the angular frequency. So it is 12 into 10 to the power 15 radian second inverse. So nu should be 12 into 10 to the power 15 divided by 2 pi hertz or second inverse. So if we calculate it, then we will obtain it is 1.9 into 10 to the power 15 hertz. So its frequency. Now what is the velocity? Okay, before evaluating the velocity, we have to evaluate the lambda. It is 2 pi by lambda, so it is 4 into 10 to the power 7, correct? So here we have, from kappa we can evaluate this, so it will be 2 pi by 4 into 10 to the power 7. So lambda is actually, if we calculate it, 2 pi means it's assuming 3.14 into 2, 6 point something divided by 4. So it is actually 1.58 into 10 to the power minus 7 meter. Okay, so this is our wavelength. Okay, 1 minute, it's okay. So 2 pi by lambda, so it should be radian per meter. Yes. Okay, now it's correct. Now, so we have already evaluated these two values, lambda and the nu. Now we know that for any wave we can write the c is equal to nu lambda, or in general we can write the v is equal to nu lambda, where v is the velocity. So v will be, nu is 1.9 into 10 to the power 15, it is 1.58 into 10 to the power minus 7, so it will be meter per second. So if we put the value, then we will obtain, it is actually c is 3 into around 3 into 10 to the power 8 meter per second. V is actually, it is equals to c, the speed of light. Okay, that should be, because we know that for electromagnetic wave, the velocity of that electromagnetic wave is equals to the speed of the light, which is 3 into 10 to the power 8 meter per second. Okay, so it is the velocity. So first part is done. So the next part is the write the equation of the magnetic field corresponding to the wave. It's also easy, nothing is there. We know that the magnetic field B, we can write B naught to sine omega t minus kx. So omega t minus kx is already given in the first part of the question in the form of the electric field. So from there we can directly copy paste. But before that we have to evaluate the B naught. What is the B naught? B naught, we know that is E naught by C. So what is E naught? E naught is 10 to the power minus 5. It is 3 into 10 to the power 8. So it will be actually 3.33 into 10 to the power minus 14. So B will be 3.33 into 10 to the power minus 14 sine omega t. What was the omega? Omega was 12 into 10 to the power 15 t minus k into x. K is 4 into 10 to the power 7 x. And what will be the unit? Unit will be the Tesla, T. Okay. Yes, I think. Okay. So this is the magnetic field, right? Now move to the second question. This is question number 2. Okay. Okay, this is an important question actually. Let me write it clearly first. A capacitor is made of two circular plates, each of radius is given, actually that is 12 centimeter, and separated by 5 centimeter. The capacitor is being charged by an external source. Charged by an external source. The charging current is constant. Okay. The charging current is constant and equal to 0.15 ampere. Okay, so what are the question? First question is calculate the capacitance and rate of change of potential difference between the plates. Difference between the plates. And the second question is obtain the displacement current between the plates. Okay, so two questions are there. First question is totally question from capacitor, and second question is related to our displacement current taught in this course, electromagnetic wave. Okay, let me do the first question. Okay, we know that V is equal to Q by C. So if we differentiate it, then we can write del V del T dV dt, or we can write 1 by C. C is constant. It's given that and it will be obviously now dq dt, and dq dt is I anyway. So it is I by C dV dt. We have already discussed that in this course as well, and in the capacitor we have already studied these things. Okay, V is equal to Q by C. From we can write that dV dt is equal to I by C. So here C capacitance is given that it is actually epsilon naught A divided by D. Okay, we know the value of epsilon naught, which is 854 into 10 to the power minus 12. Next is the A, 3.14 into 12 into 10 to the power minus 2 that's square, because that is given in I think centimeter. So we have to convert to in the SI unit. That's why you have to multiply the 10 to the power minus 2. Okay, and D is also given in the, this is D and this is our A, because we have to find out radius. What will be the radius? A equals to pi r square, right? So r is given, which is 12 centimeter. Okay, so this is the value. Now if we put D, then it will be 5 into 10 to the power minus 2. So if we put this value, then we will obtain it is 8 into 10 to the power minus 12. Okay, so it is the capacitance C. Now rate of change of, second part, rate of change of potential difference, that means dV dt. So it's also simple. It should be I by C, and I is also given 0.15 ampere, and C is 8 into 10 to the power minus 12. So it is actually, if we calculate it, then it will be 1.875 into 10 to the power 10 volt per second. This is the first question. And the second question is also clear. We know the form of ID, which is epsilon naught d phi dt. Okay, so we can write, we know that phi e is actually EA, the flux. So we can write it epsilon E dA dt. No, sorry, area is constant, right? So it should be right area here, and it is dE dt. So we can write it epsilon naught A by D, and it is dV dt. Okay, easy. So now if we put the value, it is C and it is just dV dt, then we will obtain, we know the C, it is 8 into 10 to the power minus 12, and dV dt is 1.875 into 10 to the power 10. Okay, it will be ampere. So essentially it should be equals to the current flow which is 0.15 ampere. So this is the displacement current. So this problem is also important. So let me stop in this part, here in this part. In next part I will start the radiation pressure and the intensity of the radiation. Thank you.